All right, today we are going to take a look at investigation 2.3 from our book, which is the plus-minus connection. And we are going to start by looking at this concept right here, that a plus a negative b would be the same thing as a minus b, and then do you agree, why or why not? And by the end of today, we should be able to answer that question very, very thoroughly, or at least be able to back it up with some evidence. So let's take a look at the introduction to our lesson. The lesson says that addition and subtraction are related to each other in ways that can help you solve problems. If you know that 5 plus a negative 8 equals negative 3, how can this help you find the answer to 5 minus 8? Well, we know that if 5 plus a negative 8, our negative value has a larger absolute value, which means it is going to be further away from 0, and therefore our answer, the leftover distance, is a negative 3. We know that 5 minus 8, we cannot take 5 positive numbers away, or 8 positive numbers away from 5 without having to borrow from our negative side of our number line. Let's take a look at a few problems. Okay, so the first thing we're going to do here is we are going to take a look at problem A, and the chipboard in this picture shows a value of positive 5. Okay? So question 1 says, there are 2 possible moves, one addition, one subtraction, that would change the value on the board to a positive 2. So let's take a look at that real quick. If we had a 5, how could we change it to a positive 2? Okay, so what could I do here? So we have a positive 5 to a positive 2. Well, the first idea that pops into my head after being trained in subtraction for several years is that I could just simply take away or subtract a positive 3, because I know that the difference between the 5 and the 2 is 3, and therefore in order to get from a larger positive number to a smaller positive number, I would need to subtract the difference between those. All right, so that's the first way. Well, the second way would be to involve addition of some sort. So we're going to put an addition sign in here, and then equals positive 2. Now, I'm subtracting a negative here, but what operation, or what concept is very similar to the action of subtracting a positive number? Well, by subtracting a positive number, we move left on the number line, which means we want something that will do the same thing but use addition. And this is where negative numbers come in. I know that if I'm going negative, I'm moving further to the left. But since I have to add this, I want to change the 3 from positive to negative. So positive 5 plus a negative 3 is going to equal a positive 2. So these are the 2 ways here. Okay. Now, these moves are different on the chipboard because in order to get the subtraction of the positive 3, on her chipboard, we would just have to remove 3 chips to where she's left with 2. Okay? Now, that would take care of the 5 minus 3. The other way would be to take, and since we do not have any negatives on here, that we would take and we would bring in, adding a negative 3, we would take in and add 3 red chips. And then those 3 red chips would cancel out 1 black chip for each one of our red chips, to where all that were left are 2 black chips, giving us the positive 2. All right, so that's how those moves are different. One, we'd have to add some red chips in and get rid of them. The other way, we would have to just simply remove 5 of the positive values. All right, so let's take another look at a similar type problem. So this would be A1. Let's go over here and do A2 now. Okay, so there's A2. I'll label this as A1. And it says, how would you complete the number sentences below to change the value of the board to a positive 8? So we have positive 5 plus something equals a positive 8. And then positive 5 minus something would equal a positive 8. All right, so first things first, I'm going to think about my number line. And I'm going to erase my work here real quick. And since we're starting with a positive 5, I want to make my chipboard be valued at positive 8. So I'm going to add 3 black chips to it. So that would be an addition of a positive 3. All right, so now we're going to get rid of those. We're going to start back with our 5. And I still want to get to a positive 8, but this time I have to use subtraction. So I'm going to have to subtract something. Well, I can't just put these negative chips on there just to take them back off. That's not going to change the value. See, if I put one red chip up here, which would be subtracting a negative, that means that I would have to just cancel it off, and I'm not left. It doesn't get rid of anything. Okay, so we're not just simply going to add chips this time. We're going to add what we call that 0 pair, which would be one red chip, or sorry, black chip, and one red chip, okay, to where I can have 3 negatives on the board and then subtract those and get a positive 8. So I've added 3 0 pairs, okay, this one, and this one, okay. Now I'm able to come up and we are able to take away the 3 red chips, which was the 3 numbers, negative 3, and we are left with 1, 2, 3, 4, 5, 6, 7, 8 black chips, or a positive 8. And again, 2b is kind of wrapped up in there as well. I have illustrated the differences between the two. All right, so that's how those two are connected. Subtracting a positive is like adding a negative, and adding a positive is like subtracting a negative. Each way gets us to move the proper way on our number line. So here's what I want you to do before tomorrow. Before tomorrow, I want you to finish B1, okay, all of them, and then maybe B2. So definitely for B1, you need to do those before coming to class. That way you can illustrate the point. And then A2, I want you to start looking at those patterns that you see. And again, this is found on page 40 in your Accentuate the Negative book. See you in class.